For this video, we are going to be discussing graphing linear inequalities. So graphing inequalities is very similar to graphing linear equations. All we need is a point and the slope. And we're going to be doing this from inequalities. So if I have something like y is greater than 2/3 x plus 1, well, if we think back to the last couple lessons, we know that the slope in this case is 2/3, just the coefficient of x, and we know that this right here, this 1, that's our y-intercept, and so we can say that we know we have the point 0, 1. So if I wanted to come up with another point, well, I know I'm going to go over 3 and up 2, so I can say that the next point could be like 3, 3. Right 3, up 2, 3, 3. Now that I have these 2 points, I can graph them. So it's pretty similar to graphing an equation, except just like we did with our other inequalities, we have to talk about shading and what kind of line we're going to deal with. So, well, I have a typo here. Different inequality symbols result in different kinds of lines. So if you think back to when we were graphing on a number line, we knew that greater than and less than, those gave me open circles, and greater than or equal to and less than or equal to, those gave me closed circles. Well, similarly, when we're talking about linear inequalities, we're going to deal with what kind of line we're talking about. So if I have a greater than symbol or a less than symbol, it's going to result in a dashed line. All right? And that's because the points that are on the line are not solutions to the inequality. We can think of like an example of this. This point right here is 0, 1. And the inequality is y is less than x plus 1. Well, if we try that, 1 is here, less than x is 0 plus 1, and this says 1 is less than 1. Well, this isn't true, so that point is not part of the solution. So that's what a dashed line means. However, if I have a greater than or equal to or less than or equal to, I have a solid line because the points on this line are solutions. For example, y is greater than or equal to x has this point right here, that's 1, 1. If I take a look at that, if I plug them in, 1, that's my y, is greater than or equal to 1, that's my x, well, this is true because 1 is equal to 1, so 1 is a solution. So that's the difference, okay? Greater than or less than will give me a dashed line. Greater than or equal to or less than or equal to will give me a solid line. The second thing we need to talk about is shading. So to determine which direction we're going to shade, we're going to pick a test point that's not on the line. And if that test point is a solution, so is every other point on that side of the line, and that's the way we're going to shade. If that test point is not a solution, then we want to shade the other side. And 0, 0 is a very common test point to use because it's oftentimes not on the line. So, right here I've got this line, and it's the line for y is greater than or equal to negative 2x plus 4. What I need to do is I need to determine which way am I going to color in, which way am I going to shade. The way I do that is I'm going to plug in a test point. So the test point can be any point that is not on the line. I'm actually going to do 2 of them just to illustrate the point here. So I'm going to start with 0, 0. So my test point 0, 0 here. What I'm going to do is I'm going to plug 0, 0 in for x and y. So y is going to be 0 greater than or equal to negative 2 times 0 plus 4. Well, negative 2 times 0, that's just 0. So I get the inequality 0 is greater than or equal to 4. Well, this is not true. So I know that 0, 0 is not in the solution. What that tells me is that none of the points over here are going to be in my solution, so that's not the way I want to shade. Now what I am going to do is I'm going to go over here and I'm going to pick a different point on the other side of the line. That point right there is 3, 1. Now I'm going to test this out and see what happens. So, test that out, I'm going to say 1 is greater than or equal to negative 3 times 3 plus 4. Alright, well, that's 1 is greater than or equal to negative 3 times 3 is negative 9 plus 4 That's y is greater than or equal to negative 5. Well, this is true. So that's saying that this point is in the solution. If this point is in the solution, so is every other point on this side. That's in the solution, that point's in the solution, that point's in the solution, this point. All of these points are in the solution. So what I want to do is I shade in on this side because I'm saying that every point over here is part of the solution. And also we need to realize that because this is a greater than or equal to symbol, then the points that are on the line are also part of the solution. So there we go. We've graphed this inequality. So let's take a look at a few examples of this. So example 1 says graph the solution to y is less than 3x minus 2. So this is already in slope-intercept form. I know my slope is 3, which I'm going to write as 3 over 1. That means it's 1 right and 3 up. And I know I have the point 0, negative 2, because it tells me my y-intercept is negative 2. So I can plot that point, 0, negative 2. And now I can use my slope to come up with other points. So I can go right 1 and up 3. So right 1, up 1, 2, 3. All right, I could keep doing that. Right 1, up 1, 2, 3. I could also go the other way. I can say down 1 and, I'm sorry, left 1 and down 1, 2, 3. So those points are all on my line. All right, and now I need to look and see if the points that are on the line are part of the solution. Because this is a less than symbol and not a less than or equal to symbol, I know that none of these points are in the solution, which means that this is going to be a dashed line. So I'm just going to take and I'm going to make a dashed line that goes through all of these points, and that is the line for my equation, or for my inequality. All right, so now I need to figure out which way am I going to shade. And the way I can figure that out is by picking a test point. And it doesn't matter what the test point is as long as it is not on the line. So I'm going to use the most common one. Right here I've got 0, 0. All right, and 0, 0 isn't on the line, so I can use it as a test point. What I'm going to do is I'm going to plug 0, 0 into my inequality and see if it works as a solution. So I'm going to say 0 is less than 3 times 0 minus 2. Well, 3 times 0, that's 0, so I get 0 is less than negative 2. Now I got to ask myself, is that true? No, it's not, so I don't want to shade on this side, which means that my solution is to shade on the other side of the line so that every single point that is underneath this line here is in the solution, or is a solution, to y is less than negative 3x minus 2. Alright, so what we need to do, we use the slope and the equation, or the slope and the y-intercept to graph. We look at the symbol to figure out whether it should be a dashed or solid line. And then we use a test point to decide whether or not which side we should shade on. All right, so we're going to move on to example number 2. Example number 2 says graph the solution to 9x minus 12y is greater than or equal to 96. Now this one's a little different, and it's different because my inequality is not already in slope-intercept form. So first thing we need to do is put this inequality in slope-intercept form. So we're going to start with 9x minus 12y is greater than 96, or greater than or equal to 96. And we know our first step is going to be to subtract 9x on both sides. So I get the inequality negative 12y is greater than or equal to negative 9x plus 96. I know that my next step is going to be divide everything by negative 12. And I know that because I'm dividing by a negative, this sign is going to flip directions. And I end up with y is less than or equal to negative 9 divided by negative 12 is 3 divided by 4, so 3/4 x. And then 96 divided by negative 12 is minus 8. So now I have my inequality in slope-intercept form. I know my slope is 3/4, and I know I have the point 0, -8, and I use this information to graph. So I'm going to first start. Here's 0, -8. All right, and now I know that this is 3 up and 4 right. So I can go up 3, 1, 2, 3, and 4 right, 1, 2, 3, 4. Gives me the point -5, 4. Now that I have 2 points, I can draw my line. Because this is a less than or equal to symbol, I know that I'm going to have a solid line. So I'm just going to draw a solid line that goes between these 2 points, just like this. Make it a little extra long so that I can come back and put it in like this. And now I need to determine which way I'm going to shade. And to do that, I'm going to pick a test point. 0, 0 isn't on the line, so I'm going to use that one. So if I plug it into my inequality here, 0 less than or equal to 3/4 of 0 minus 8. Well, that tells me 0 is less than or equal to -8. That is not true. So my solution is not over here. My solution is down in the corner here. So all I'm going to do is I'm going to shade in this corner, telling me every single point in this corner is in the solution to my inequality. So that's all we do. First thing we do is make sure it's in slope-intercept form, then use our slope and y-intercept to come up with another point, determine whether it should be a dashed or solid line, then draw the line, then use a test point to figure out which way to shade. So your try-it problem for tonight is to tell me which of the graphs below shows the solution to 3x plus 2y is greater than 8.